this video covers another example of a free body problem where there are two objects placed on top of one another. So in this video, we will be talking about two free body diagrams, and these two free body diagrams are for a kid that sits on a sled while sliding down a hill. So we know that there are two different objects in this problem, so we're going to draw a free body diagram for both of the objects. So we have one for the kid and one for the sled. And since these two objects are on Earth, we know that they both have a weight force acting down. And we also know that since they're on a hill or a surface, that they also have a normal force that is perpendicular to the hill. So let's look at the sled for a moment. We know that since the sled is sliding or slipping on the ground, that there is a kinetic friction force that opposes the velocity. And then we can also look at the kid and think about how the kid stays on the sled while it's traveling down the hill. And the kid stays on the sled because of a static friction force that aids in accelerating the child down the hill. So at the moment, these are all the forces that act on the kid. But since the kid is on top of the sled, we have to ask ourselves if there are any forces that act on the child because of the sled. So from what we have discussed about normal force, we know that the normal force is the force exerted on the kid by the sled, so therefore the normal reaction force is the force exerted on the sled by the kid. And take note that the normal force reaction vector is the same size but opposite in direction as the original normal action force vector. We also would say that the static friction is the force exerted on the kid by the sled, so therefore the static friction reaction force is the force exerted on the sled by the kid. So now we have all the forces labeled on our two objects.